Okay, hello everyone. Okay, let us continue the second part of today's class. Okay, please open the slides. Okay, and turn to page 48 of chapter 2. Okay, so we are talking about section 2.2, Deep Q Learning and Resource Allocation. Okay. An alternative approach is to estimate together the action value function, also called the Q function, that maps the Q values as a function of the state action pair of variables. Okay, we have introduced what is the Q learning, okay, including a Q function and Q values. Okay, if you forget, you can review the chapter 2. Chapter 2. Handout of chapter 2 and search for Q learning. Okay, so we have introduced what is Q learning in problem 2 on page 14. Okay, if you forget it, you can review the solution. Excuse me. Okay, to follow this approach, neural networks can be used as function approximators of the action value function and compensate for the limitations seen with the standard table-based Q-learning algorithm in terms of generalization and function approximation capability. Okay, a deep Q network DQN is an emerging class of deep reinforcement learning algorithms that is capable of combining the process of RL, okay, that is reinforcement learning, okay, with a class of neural networks known as deep neural networks. Okay, so if sometimes you see a word, an abbreviation DNN, okay, it means deep neural networks, to approximate the action value function. Okay, so when we talk about deep Q network, we are talking about the deep Q learning. Okay, and we have introduced what is the deep Q learning. Okay, if you forget, okay, you can open the let me see. Okay, you can open the handout of chapter 2. Okay, and you can see that we have introduced what is deep Q learning on page 15. Okay, so we also introduced what is the Q value function. Okay, here. Okay, in the problem 2, what is a Q value function? Okay. So let us go back to the slides. Okay, so do you know what are deep reinforcement learning algorithms? Okay, these algorithms combine deep learning, okay, and reinforcement learning. Okay, the team at Google DeepMind, okay, I think you should be very familiar with Google. Okay, for example, I use Google every day. For example, Google Calendar and Gmail and Google Search. Okay, like this. Okay, so what is DeepMind? Okay, let us see the handout. Okay, so please open the handout of chapter 2 and search for DeepMind. Okay. Okay, so this is page 49, problem 1. What is DeepMind? Okay. Solution: DeepMind Technologies is a British artificial intelligence subsidiary of Alphabet Inc. Okay, and research laboratory founded in September 2010. Okay. Then what is the meaning of subsidiary? Okay, let us see problem 2. What is subsidiary? Okay, solution: a company that is owned by a larger company. Okay, so let us go back to the slides. Okay, DeepMind pioneered the use of this technique. What is this technique? This technique means the deep neural network. Means the DQN. Okay, deep Q network, and demonstrated superhuman performance for a single learning agent playing Go. Okay, what is Go? Okay, let us see the handout. So, where are we now? Okay, Go. Okay, good. Okay, so it is not easy to control. Okay, good. Problem 3. What is Go? Okay, solution: Go or 围棋. Okay, simplified Chinese is these two words, 围棋, and traditional Chinese. Okay, I think you must hear this before. Okay, 围棋, 拼音围棋, is an abstract strategy board game for two players in which the aim is to surround more territory than the opponent. Please see figure 33. Okay, so let us see figure 33. Okay, let me make it smaller. Okay, and more smaller. Okay, so let me try 100%. Then I can use maybe 200%. Okay, good. So figure 33, Go is played on a grid of black lines, usually 19 times 19. Okay, so you can count, there is 19 lines. Okay, and here is 19 lines. Okay, game pieces called stones are played on the lines intersections. Okay, so it is a Go. It is a board of the game Go. Okay, and with black stones and white stones. Okay, so let us go back to the slides. Okay, playing Go and video games. Okay, please see Mini et al. In 2015. Okay, we can see that in 2015, okay, Mini et al. Okay, published a paper. The title is Human Level Control Through Deep Reinforcement Learning. Okay, which is published in Nature. Okay, Nature is a journal of very good quality and has very high impact factor in 2015. Okay, and Silver et al. In 2016. Let us see. Okay, Silver et al. Okay, published a paper, Mastering the Game of Go with Deep Neural Networks and Tree Search. Okay, which is also published in Nature in 2016. Okay. Okay, a second dimension of the resource allocation problem we will expand upon pertains. Okay, what is pertains? Okay, let us look at the handout. Okay, so let me search for the pertain. Okay. Okay, problem 4. What is pertain? Oh, sorry. Pertain. Okay. So, solution: to be connected with a particular subject, event, or situation. Okay, so let us go back to the slides. Okay, pertains to new fuzzy. Okay, what is fuzzy? Okay, let us see the handout. Okay, problem 5. What is fuzzy? A solution: the plural of focus. Okay, and I think you have already known what is the meaning of focus. Okay, it is a basic word. Okay, I think you may have learned it in junior high school or senior high school. Okay, so let us go back to the slides. Okay, to new fuzzy in network design that are brought about by the development of 5G wireless systems. Okay, the evolution of wireless communications toward the 5G era involves a transformation in network design and evaluation that aims at placing the end user at the center of any decision. Okay, the end user is just you and me. Okay. As a result, resource management techniques for 5G networks need to be based on quality of experience, okay, which is abbreviated as QoE. Okay, what is quality of experience, QoE? Okay, let us look at the handout. Okay. So it is page 50, problem 1. What is quality of experience, QoE? Okay, solution: quality of experience, QoE, is a measure of the delight or annoyance of a customer's experiences with a service. For example, web browsing, phone call, TV broadcast. Okay, and what is the meaning of the word annoyance? Okay, please see problem 2. What is annoyance? Okay, solution: the feeling or state of being annoyed. Okay, so next let us see what is annoy. Okay, problem 3. What is annoy? Okay, solution: to make someone angry. Okay, let us go back to the slides. Okay, so based on quality of experience, QoE performance assessment, please see Wu et al. 2014. Okay, let us see Wu et al. Okay, have written a paper which of the title a learning-based QoE-driven spectrum handoff scheme for multimedia transmissions over cognitive radio networks, which was published in IEEE Journal on Selected Areas in Communications, 2014. Okay, this journal. Okay, usually when we talk about this journal, usually we say JSAC. Okay, JSAC. Okay, it is also a very important journal in the area of telecommunications and has very high impact factor. Okay, so let us go back to page 50. Okay, next page, the shift in performance assessment from objective. Okay, what is objective? Okay, so please note that the meaning of this word is not 目标 here. Okay, it has another meaning here. So let us see what is, objective, not objective. Okay. Okay, so this is page 51, problem 1. What is objective? Okay, solution based on real facts and not influenced by personal beliefs or feelings. So in Chinese, it means 客观的. Okay, so let us go back to the slides. So the shift in performance assessment from objective QoS matrix. Okay, we have introduced what is QoS. Okay, if you forget, please open the handout of chapter 2. Okay, and search for QoS. Okay, and you will find we have introduced it in the solution to problem 1 on page 21. Okay, so back to the slides. So objective QoS matrix to subjective. Okay, what is subjective? Okay, let us look at the handout. Okay, and search for subjective. Okay. So problem 2, what is subjective? Okay, solution influenced by or based on personal beliefs or feelings rather than based on facts. So the Chinese meaning of the word subjective is 客观的. Okay, let us go back to the slides. Okay, subjective end-user QoE matrix has been added by a number of studies in multimedia quality assessment that have contributed techniques to estimate the QoE from objective measurements while retaining high correlation with the subjective perception of quality. Okay, what is the meaning of the word perception? Okay, let us go to the handout. Okay. So problem 3, what is perception? Okay, solution, the quality of being aware of things through the physical senses, especially sight. Okay, so let us go back to the slides. Okay, so if you want to translate this word into Chinese, okay, I think it means 感知. Okay, 感觉的感，知道的知. Okay, among these techniques, mean opinion score, which is abbreviated MOS. Okay, a metric rating from 1 bad to 5 excellent is the most widely used QOE metric. Okay, please see the reference Chen et al. 2015. Okay, so please see this reference. Okay, the authors of this paper is Yang Jiao Chen, Kai-Sheng Wu, and Qian Zhang. Okay, and the title of this paper is From QoS to QoE, a tutorial on video quality assessment, which was published in IEEE Communications Surveys and Tutorials in 2015. Okay, it is also a very high quality journal in the field of telecommunications. Okay, the ranking of the impact of this journal in the field is in the field of telecommunications is number 1. Okay, so it is the best journal in terms of impact, the impact factor. Okay, so next page, as a third dimension to delve. Okay, what is delve? Okay, let us look at the handout. Excuse me. Okay, so page 52, problem 1. What is delve? Okay, solution. Okay, to search, especially as if by digging, in order to find a thing or information. Okay, this is delve. Okay, let us go back to the slides. Okay, as a third dimension to delve deeper into the resource allocation problem, we will consider that different SN, okay, that is the secondary network links. Okay, do you remember what are secondary network links? Okay, if you forget, let us review it in a few minutes. Okay, so in this figure 2.1 is the overview of the network setup. That is the focus of this chapter. Okay, so you can see that here is the SN link, okay, the secondary network link, and here is another secondary network link. Okay, from this little small base station to this CR, okay, that is cognitive radio device. Okay, so we use a brand to denote the cognitive radio. Okay, and this is the same. Okay, so let us go back to page, okay, maybe 52, I think. Okay, good. So different secondary network links may be carrying different types of traffic. For example, one link may be carrying delay-sensitive real-time video. Okay, for example, I use my cell phone to see a YouTube video. Okay, that is the delay-sensitive real-time video. Okay, because I do want to have delay when I am watching the video. Okay, while another link may be seeing regular data traffic. Okay, for example, I am checking my Gmail using my cell phone. Okay, then my cell phone will download some data traffic from the link. Okay, in the context of distributed resource okay, it is 25 minutes. Let us take a break.